So our new chapter is rational expressions and rational equations. So we're going to just start off with simplifying rational expressions. Okay, so a rational expression is an algebraic expression, so it has variables such that the numerator and denominator are polynomial. So this is an example right here of a rational expression. So no equal sign. I have a trinomial in the numerator and a binomial in the denominator. Okay, remember, each one of these are terms and they're separated by addition or subtraction signs. Remember, trinomial is 3 terms, binomial is 2. So in order to simplify these, I listed out the steps for you so you don't forget. So if you had binomials or trinomials or anything bigger than that, you would need to factor if you could. Okay, but in this case, in number 1, I just have monomials. So there's no addition, subtraction signs. I just have these terms above each other. So what you're going to do is first simplify the numbers normally if you can. So I have 42 over 12. Think about if you had 42 over 12 as one of your answers on a test and I told you to simplify your answer. How would you simplify it? Well, 6 goes into both of these, right? So I could divide both of these by 6. So 42 divided by 6, that becomes 7, and that becomes 2. So right now I have 7 in the numerator, 2 in the denominator, and then we're going to use exponent rules. Remember that? You do big minus small, so 7 minus 3, that's 4. So I have p to the 4th, but p to the 4th has to stay in the denominator because 7 is the bigger exponent between 7 and 3. Okay, and then that's your final answer. So we've actually already did problems like this before when we did exponents in the first semester. So number 2, now I have binomials. So what I need to do is factor what I can first. So that means look for GCF. So in the numerator, what goes into both 35 and 7? Well, that's 7. So I'm going to pull out that 7, and I get 5x minus 1 left. Okay, and then I'm going to do the same thing in the denominator. What goes into both 35 and 56? Well, that's 7. That's the GCF. So I have 7x minus 8. Now that I factored out 7 as a GCF, I could simplify that. I could cross that out. So these 7s are going to cross out with each other, right? 7 over 7 is just 1. And then I have 5x minus 1 equals 7x minus 8. Now you can only cross out terms or whole binomials or whole trinomials, but you can't cross out pieces of a binomial. So in this example, in number 2, I can't just cross out the 35x's and then say I have 7 over 56 left. It doesn't work like that because 35x is a part of a binomial. Okay, see, now you would ask, well, then why can I cross out the 7? Well, when I factored out the 7, it's not a part of the binomial anymore. Okay, it's becoming its own term. So then I could cross it out. So you can only cross out GCFs or entire binomials or entire trinomials that match, but that's it. You can't cross out pieces of your binomial. So number 3, I'm going to factor the numerator. Remember, I'm going to go into my 2 parentheses, and it's got to multiply to be 9, but add to be negative 8. So that's negative 9 and positive 1. And then in the denominator, I can't factor that. Now, in the steps, I said cross out a pair of matches. Okay, so I'm looking for binomials, whole binomials that match. So I have one from the numerator, one from the denominator. Okay, it can't be on the same level. One has to be on the top and one has to be on the bottom. Now, these match exactly, so I could cross those out as a whole. Notice I'm not crossing out pieces of them. I'm crossing them out as a whole. And then my final answer is just what's left, what I didn't cross out, which is n minus 9. And then that's your final answer. Okay, number 4. So I got to factor the numerator. So it's got to multiply to be negative 8, add to be negative 2. So that's negative 4 and positive 2. And then in the denominator, it's got to multiply to be positive 20, but add to be 12. That's 10 and 2. Okay, notice I have two binomials that match exactly. So those can cross out, especially because one's in the numerator, one's in the denominator. So then I'm going to write what I have left, r minus 4, r plus 10. You cannot simplify the 4 and the 10. You cannot simplify the r's. You cannot cross out those r's because they are a part of a binomial. So either they match exactly and you cross them out, or you leave them as is because you cannot cross out bits and pieces of binomials and trinomials. So this has to be your final answer. Okay, number 5. So I have 5 minus x over, I'm going to factor the denominator. So multiply to be positive 20, add to be negative 9. So I have x minus 5, x minus 4. Now hopefully you're noticing that these match almost, right? 5 minus x isn't the same exact thing as x minus 5, but there's something I could do to make them the same. Okay, it's the same two terms, but they are opposite signs. So to fix that, I'm going to factor out a negative 1. So I'm going to take out a negative 1. If I did that, this 5 would become negative, and this x would become positive, right? And everything else would stay the same. Well, think about it. If I rearrange this, how could you make that look different? I can make this look like x minus 5, right? So I'm factoring out the negative 1. I changed the signs, and now the x minus 5 matches the x minus 5 in the denominator, and they're fair game to cross out completely. So then my final answer would be negative 1 over x minus 4. Okay, again, I knew to do that because these were the same but opposite signs. So to change the signs, you take out a negative 1, and then they end up being the same thing. Okay? And number 6, I'm going to factor the numerator. So it's got to multiply to be positive 36, add to be negative 6. So that's, negative 12. So that's negative 6 and negative 6. In the denominator, I see that I have a GCF, right? They all have x in common. So I'm going to factor out that x first. And then I'm going to continue to factor what's left in the parentheses. So the numerator is going to stay the same. And then in the denominator, I have x, and then I'm going to factor what's in the parentheses. So it's got to multiply to be 6, but add to be negative 7. So x minus 6, x minus 1. Okay, and I'm looking for matches. So something from the numerator that matches with something in the denominator. Well, I have a pair of x minus 6. So you can't cross out all three. You can only cross out a pair. So I'm just going to choose one. It doesn't matter which one. Let's just say I'm going to cross out this x minus 6 with this x minus 6. Now the other one's got to be left alone because it doesn't have another x minus 6 to cross out with. So literally my answer is going to be what's left. I have x minus 6 left in the numerator. I have x in the denominator, and then x minus 1 also in the denominator, and that's your final answer. Again, I can't cross out this x with this x because the top x is a part of a binomial, and that cannot be crossed out. Okay, number 7. So before I completely factor, I see I have a GCF in the numerator of a, so I'm going to take that out. So then I have 2a squared. Oh, sorry, I have a bigger GCF than that. It's 2a. So I get a squared minus a minus 2. In the denominator, I have a GCF of 8. So then I get a squared minus a minus 2. Okay, so before I keep factoring, notice that these are exactly the same. That's fair game to cross out the entire thing, okay? If you have a pair of parentheses that match exactly, those cross out with each other. Also, now that these are GCFs, they're not a part of the trinomials anymore, so those could also be simplified. So I could simplify 2 over 8, right? 2 goes into both of those. So that becomes 1, and that becomes 4. So what I have left in the numerator is just that a, and in the denominator I have that 4. Now if those trinomials didn't match exactly, you would have to factor those out and see what matches, but since they did match exactly, I didn't have to continue to factor. I saved myself some time and just crossed those out right away. Okay, finally number 8. I'm going to factor the numerator, so there's no GCF, so I'm going to have to guess and check. So remember, it's 5m and m. That's the only way you could break up 5. And you have to guess with factors of 8. Well, it's multiplying to be a negative, so 1's plus, 1's minus. I could do 2 and 4. That won't work. 8 and 1 I think will. So 1 and 8. 5, negative 5 plus 8. That gives me positive 3, which is the term in the middle. Okay, so I factored that correctly. So I'm going to erase that. In the denominator, I do have a GCF of 5. So I get 3m squared minus 6m plus 3. Now I have to keep factoring what's in the denominator. So the numerator is going to stay the same. Sorry, that looks like 15. Okay, and then I have the 5, and I'm just looking at what's inside the parentheses in the denominator. So I know it's got to be 3m and m, right? That's the only way you could break up 3. And it's multiplying to be a positive number and adding to be a negative, so I know it's got to be minus minus. Okay, and then I'm going to guess with factors of 3. Well, I only have 3 and 1. Remember, the 3 can't go in this parentheses because there'd be a GCF. So I'm going to put the 3 over here and the 1 here. So I get negative 9 minus 1. That did not work. 5. Okay, hold on. So with number 8, I got to factor the numerator. There is no GCF, so that means you can't just put m and m in the front, right? You got to break up 5. So the only way you could break up 5 is 5m and m. And it's multiplying to be a negative, so I know it's got to be plus minus. And then you've got to do guess and check. So I got to guess factors of 8. So let's see, 4 and 2, that wouldn't work. 8 and 1, looks like that would work. Remember, you guess where the factors go, and then you check by multiplying your outsides and your insides and adding them together to see if it gets you your middle term right here. I get 3m, so it matches my middle term, which means I factored it correctly. So I'm going to erase this, and then I'm going to move on to the denominator. So there's a GCF of 15. So I'm going to factor that out first. So I get m squared minus 2m plus 1. Oop. And then I got to keep factoring what's in the parentheses. So the numerator stays the same. And then I get 15, and then in the denominator, factor what's in the parentheses, I get m minus 1, right? Because it's got to multiply to be positive 1, add to be negative 2. And now I'm looking for matches. So one pair of m minus 1 can cross out. Everything else stays. So in the numerator, I have 5m plus 8 left. In the denominator, I have 15 and another m minus 1. Again, I can't simplify the 5 and the 15 because the 5 is a part of a binomial where the 15 isn't. Okay, the 5 is a part of binomial. You cannot do that, so you got to leave your answer as is. Okay, so I have 2 U-tries. You could do them along with me, or you could try and see if you get the concept and then check back with your answer, replay the video. Okay, so with number 9, I could actually factor the numerator. So there is a GCF of 2. So I get 7b plus 6 in the parentheses over 12. Now that I've taken the 2 out, it is not a part of the binomial anymore, and it is fair game to simplify. So I'm going to simplify the 2 with the 12. So the 2 goes away, and the 12 becomes a 6. So I get 7b plus 6 over 6. Now these 6's cannot cross out because that 6 in the numerator is part of a binomial. Okay, it's attached by addition. If it's attached by addition, you cannot touch it. If it's attached by multiplication, it is. Okay? And number 10, I'm going to factor the numerator, multiply to be 21, add to be negative 10, that's negative 7, and negative 3. And then in the denominator, multiply to be negative 3, add to be 2. Sorry, negative 2, so that's negative 3, positive 1. Look for a pair of matches, so these match. You could cross them out as a whole. So then I have a minus 7 over a plus 1. Okay, you cannot cross out the a's because they're part of a binomial. So that leads us to our most important rule. And if you had me in actual school, you would hear me say this a lot. Don't bust your binomials. Okay, what that means is your binomials and your trinomials are a package deal. Okay, so in number 11, x plus 3, x minus 4. So the 3 and the x are a package deal. You either cross it out as a whole or you leave it alone. The x and the 4, those are a package deal. They're attached by subtraction. You can't cross out these x's and say I have 3 over negative 4. Literally, you have to leave your answer as x plus 3 over x minus 4. Okay, you cannot separate binomials. You cannot separate trinomials. So you also can't bust your trinomials. Again, they're a package deal. Either you cross them out as a whole or you leave them alone. Do not cross out bits and pieces of those. Okay, I hope that makes sense. Please let me know if you have any questions.